So what's our problem is we're given a set of points and we're given a set of intervals, and we want to find the smallest subset of the intervals, right? For each interval, we either take it or we don't take it, and we want to take as few intervals as possible, but they have to cover all of the points, right? Everybody got that? Greedy. So now we need a greedy criteria. The obvious greedy, you know what? This man here asked, right? When you have a brand new problem, if it's an optimization problem like this, where you're making a decision, a bunch of objects, what should you do first? And what I say you do first is think about the obvious greedy algorithms, determine whether they work or not. They don't work, why don't they work? And then if none of them work that you can think of, then you have to go up to dynamic programming. And if you can't get that to work, then you try to prove that it's NP complete, right? I think that's pretty much the entire game, right? All right, so here, which interval should we take first? It feels like the interval that covers the most points, right? And do you think that works? Probably not, right? Everybody buy that this is proof that this algorithm doesn't work, right? Because, I didn't even say, because it's going to take this interval because it covers the most points, and optimal is to take the bottom two, right? Everybody buy that? Right? Because if you take this first one, you still got to cover those outer ones, right? So you have to take the other two as well, in which case you didn't need to take the middle one, right? Yeah, two, exactly. All right, so here's another possibility. Oh, this is the algorithm in question. It's a little more subtle, but it's kind of also what you would think, right? I also say, try to think about looping variant algorithms, right? Iterative algorithms. And because these points are in a line, the intervals are in a line, so it's natural to start at the left and move to the right, right? It's just natural. So let's look at this leftmost point. It needs to be covered, right? So consider all intervals that cover it, right? And which one do you take? The one that goes not the most, it goes right the furthest, right? We don't care about left. Why not? Because we've covered the left. We've done the left. And right now there is no left, right? Take the one that goes furthest to the right, right? Greedy. Take your first point that's not covered, right? Take the intervals that cover it. Take the interval that goes furthest to the right, right? Why it's just to the right is because we've covered to the left, right? And that's the algorithm, right? And it's okay if they overlap, right? That wasn't part of, as soon as if you start asking things like, I don't want them to overlap, then you're getting into bin packing kind of things. It's going to quickly be NP complete, right? Because we can go for the guy who goes furthest to the right. Because if it goes too far, we don't care if it overlaps. Yeah. Yeah. It's not the longest, it's the one that goes furthest to the right, right? So that's that one, right? I knew I was right because I've taught from these slides many years and nobody has found a mistake yet. So if you were the first, then it would have been surprising. Everybody good with the algorithm? All right. So do you need a review of this part? right? We're focusing on the game, right? So if we jump ahead to the game, right? What's the first step of the game is that the algorithm has committed to some intervals, right? And the fairy godmother has a full solution, which may or may not be optimal, and which is consistent with what the algorithm has done, right? And then the algorithm, let's think about what the algorithm does. It takes the point that's the leftmost uncovered point, considers its edges, and takes the one to the right, right? So that's that goes furthest to the right. So that's what the algorithm takes, right? But the fairy godmother, I mean, if she had it, that would be great. But if she doesn't have it, right? She doesn't have it. So what will our instructions be to her? Take it and drop that. So I will give you some marks for that because well, I might, let me tell you. Yeah. Let me tell you what I don't like about your answer. You use an it and a that, and I don't know what it or that is. So this is a very, very common reason for me to take off marks when I'm marking. If you ever say it and I don't know what it is, you lose marks, right? So in this case, you do add it, and it is the thing that the algorithm added, right? And you do drop that, which is, yeah, but which of the things? She has many, many things. That's where you
left, I guess the leftmost that she has.
You know what? That covers that point. That's the key. That's right? All right, so let me say it another way. She may have many things that cover that point. And we could drop one of them, or we could drop all of them, right? So I'm gonna, yeah. Yeah. Yeah.
That's correct. But how about the second one? Is the one right?
Well, all right, so yeah, you might be right. It might be that the algorithm took this one. All right, so let's, yeah, you might be right. And I'm going to say, no, you're micromanaging our algorithm. All right. So I've been told that this is what the algorithm is committed to. And maybe it's not following the algorithm perfectly. In fact, the only thing I'm going to use about what the algorithm gives me is that the points are covered until they're not covered anymore, right? So, I mean, maybe we could roll back and see what does the algorithm actually do. Right. Actually, I think the algorithm here, that's the next one. So we get that edge. Right, of the intervals that cover this point, this is the one that goes furthest to the right. Right? So we took it. Right, does that make sense? Yeah. Yeah, and we don't care about furthest to the left. Yeah, so that's, I mean, I would have been surprised if it was different because I'm a copy paste. I copied this, but I was worried that she was right. But now we see, this. Yeah. Yeah. No. These are all covered by this blue. The leftmost uncovered point is this, right? So what covers it? These cover it. Which one of these, which goes furthest to the right? It's this one, right? Does that make sense? So we are now going to tell her, I'm going to say, hey, fairy godmother, this is the point the algorithm just cared about. And you have to have covered it with at least one interval, right? So we could ask her to drop just one of them, but we're going to be greedy. And we're going to tell her to drop any interval that covers that point. All of them, just drop them all. And put in the one ours, right? Does that make sense? That's the instruction, right? So she does that, right? And now we have to prove, does it extend? Well, again, here we have to be a little subtle. We have to make sure we didn't delete anybody earlier, right? But why didn't we delete those? Because it didn't cover the point in question, right? So we're not deleting the earlier thing. We are adding the one that the algorithm cares about. And so we're good. Everybody good with that? All right, so now, is it just as good, right? Well, we made sure, we know she's gonna, we know she has that point covered. So we're dropping at least one of her intervals and we're adding one interval. So our solution is at least as good as hers, right? And if hers was optimal, ours is optimal too, right? Everybody right? All right, now we have to prove that it's valid, right? And I'll tell you another good way to get low marks is you talk about valid and talk about conflict without telling me what valid means. Minimally, go back up and read the question and see that valid means that she's covered all the points, right? So now I come back and say, I got to prove that ST covers all the points, right? So how do I know that she covers these points? Because the algorithm has covered them and she's consistent with that, right? How do we know she's covered this point? Because the algorithm covered it and we're consistent with that, right? How do we know she's covered these? Right? Well, she used to cover them. ST-1 covered them, right? And what did she drop? Everything she dropped are intervals that covered that point. So everything she dropped, we personally, the algorithm considered in this round, right? And of the intervals that the algorithm considered, it took the one that went furthest to the right. So we put in it, like, we're not worrying about these points anymore. We're worrying about these points. And we put in an interval, we took out a bunch of intervals, right? But the interval we put in went further to the right than anybody that we took out, right? So if she had covered all of these points to the right, it still covers them, right? Everybody good with that? And that is kind of like, that's kind of what I said, and we're done. Right, good. We close up shop, and oh, how much do we got time still? 5 minutes. All right, so how are you going to implement this, right? And one of my favorite ways of implementing things is to have an event queue. Have you heard about event queues, right? So you can imagine there are, maybe I have jobs that I need to do, or there are events that are going to happen. And when I, time wheel. Yeah, okay. I've never heard of a time wheel, but I'll buy it, right? So when I know about a new event or a new job that I need to complete, maybe, I just learned I talked to my mother and she said, here are a bunch of jobs to do. So I put them in my queue. Why do I put them in my to-do list? Because I can't do them all at once, right? When I learn of a job, I put them in the queue, and they're sorted based on the order I want to do them. And when I want to do a job, I take it out of the queue, right? And I do that job, but maybe doing that job creates more jobs, right? It's the nature of jobs, right? There's something broken in your house, so you open up the wall, and let me promise you, you find more jobs, right? So then you have all these new jobs and you put them in the queue, right? I mean, it's a great way to solve algorithms, right? For example, if you know Sudoku, if I wanted to write a program, I would know that there were these things I needed to check. And as you check one, you learn other things you need to check, right? But anyway, here's going to be our event queue. And we're going to move left to right. And when we hit the beginning of that interval, then we know about this interval and we put it in our priority queue, right? And then we move further and we learn about this interval and we put it in our priority queue. We move when we hit this point, right? And so we have to say, which one do we cover it with? It's not covered, right? We have a bunch of things we've committed to, but we haven't committed to anything yet. So that point's not covered. Who do we cover it with? Right, we pop off the priority queue the guy who furthest to the right, right? And so he's popped off the priority queue, and that's good. We get the next interval, we put it on the priority, right? Now we see this point, what do? It's covered, we ignore it, right? Point, ignore. Now this interval is ending. Here, what you would think you would do is nuking, right? And nuking is perfectly reasonable because it's not used to us. But here's a subtle thing is, no, because it's ended, right? It's short. It's not useful. But here's a little point, is you don't actually have to take it off because it's so useless, it will never come up, right? It can just stay at the bottom of your priority queue. Cheaper to keep it there to take it out. All right. So don't take it out. It doesn't do any harm. All right. So we move over to we put this guy in. We get this point. It's covered, so ignore it. We get this interval. We put it in. Now, what's in the priority queue? All of these intervals. And you'll note how the fact that this guy's still in there is not hurting us, right? We take the guy with the highest priority and we cover it. Right? Everybody get this? And so we can keep doing it, and it's the same deal. And so what's the running time of this algorithm? Log in to sort the intervals, right? Or actually, we're not even doing that. We're discovering it as we go. But when you put an object into the priority queue, it takes login time to bubble up and down, right? So each of our edge intervals will take us login time. So it's in login, which was the time to sort anyway, right? Yeah, but you get them in order, right? It's adaptive. That's the point. It's adaptive, right? Everybody good with that? And yes, effectively, you're putting things in the heap. You're taking things out of the heap. You're doing some sort of heap sort, right? And that is it. That is it. That's just keep doing the same thing. There's the code. It's not very exciting.